Hello everyone. Today I am going to start MQTT tutorials. This is the course outline. Firstly, I will talk about what is MQTT. After that, we will see some unique properties of MQTT which is hardly found out in any other protocols. Thereafter, we will see brief story of MQTT and then we will look MQTT architecture and then we will dive into the MQTT message format and what is quality of service. Now, let's start with what is MQTT. MQTT is machine-to-machine Internet of Things connectivity protocol. It was designed as an extremely lightweight publish-subscribe messaging transport. It is useful for connection with remote location where network bandwidth is at premium. These characteristics make it ideal for use in many situations, including constant environment, such as for communication in machine-to-machine and Internet of Things context. The protocol runs over TCP/IP or over other network protocol that provide lossless and bidirectional connections. So, the MQTT has unique features to be noted down. You can hardly find in other protocols. Like as I said before, it is a machine-to-machine protocol. It is designed as a lightweight messaging protocols that uses publish subscribe operation to exchange data between client and server. It does not require that the client and the publisher are connected at the same time. It is fast in data transmission, just like Messenger and WhatsApp message delivery is. It's a real time. Clients subscribe to a narrow selection of topics and only receive the information they are looking for. That's why MQTT is one of the most commonly used protocol in IoT projects. Now, before going further, let's see the brief story of MQTT. MQTT was invented by Dr. Andy Stanford Clark of IBM and Arlen Nipper of Arcom, which is now Erotech. The version The previous protocol version 3.1 and 3.1.1 was made available under MQTT.org. In 2014, MQTT was adopted and published as an official standard by Oasis. As such, Oasis has become the new home for the development of MQTT. The Oasis technical community is tasked with the further development of MQTT. Version 3.1.1 of MQTT is backward compatible with 3.1 and brought only minor changes, just like changes restricted to the connect message and clarification of version 3.1. That is mostly editorial changes. Now, there is a recent version MQTT version 5.0, which is the successor of MQTT 3.1.1. So now you are thinking, why not the version 4? There is an interesting fact behind this. If you want to know, then let me know in the comment box. Mostly important, MQTT version 5.0 is not backward compatible like version 3.1.1. Obviously, too many new things are introduced, so existing implementation have to be revisited. According to the specification, MQTT version 5.0 adds a significant number of new features to MQTT while keeping much more of code in the place. The major functional objectives are enhancement for scalability and large-scale system in respect to setup with thousands and millions of devices, improved error reporting, and of course, performance improvement and improved support for small clients. Before we start the architecture part, let's start with the various components of MQTT, like message, client, server or broker, and topic. Let's look one by one. Now, what is message? the data carried by the MQTT protocol across the network for any application. When message is transported by MQTT, it contains the payload data, a quality of service, a collection of property, and a topic name. When we will see the message format, then these all terms will be cleared. Now, when to say a device working as a client. Clients subscribe to topics to publish and receive messages. Thus, subscriber and publisher are the special roles of a client. Or in a general term, a program or device that uses MQTT are referred to as client. Or if we say more specifically, a device is a client when it opens the network connection to the server, publishes messages that other client might be interested in, subscribe to request messages that it is interested in receiving, unsubscribes to remove a request for messages, close the network connection to the server. In MQTT, client perform two operations. When a client sends data to the server, we call this operation a publish. When a client receives data from the server, we call this operation a subscribe. Now, what is server? A program or device that acts as an intermediary between client which publish messages and client which have made subscription. If we say more specifically, a server accepts network connection from client, accepts message published by clients, process subscribe and unsubscribe request from client, forward messages that match the client subscription, and closes the network connection from the client. Now, what is topic? The label attached to a message which is matched against the subscription known to the server. More technically, topics are message queues. Topics support the publish subscribe pattern for client. If we say logically, topics allow client to exchange information with defined semantics. Example, temperature sensor data of a building. Now, let's look at the architecture of MQTT. To get a better understanding, let's take an example. Let's say there is a device that has a temperature sensor. Certainly it wants to send his reading to the server or broker. On the other side, a phone desktop application wants to receive this temperature value. Therefore, here two things will be happen. The device defines the topic it wants to publish. Example, say temperature. Then it publishes the message temperature value. The application, the phone or desktop application subscribes to the topic temperature. Then it receives the message that the device has published, which is the temperature value. Again, the broker or server role here is to take the message temperature value and deliver it to the phone or desktop application. Here, this is the broader picture of the working of MQTT architecture. In this lecture, I am going to start MQTT message format. Before starting message format, it is important to note that MQTT uses command and command acknowledgement format. That means each command has an associated acknowledgement. Like as shown in the figure, connect command has connect acknowledgement, subscribe command has subscribe acknowledgement, publish command has publish acknowledgement. It is similar to handshaking mechanism. Now, let's see MQTT packet structure, or in general term, MQTT message format. The MQTT packet or message format consists of a 2-byte fixed header which is always present in a message, and variable header which is not always present, and payload which is also not always present in the message. Payload contains the data being sent. So you're all thinking that payload section is compulsory, but we will see in the later slide that many command in MQTT does not require payload, or in other words does not contains the message data to be sent. Example like disconnect message. This is a fixed header format. As you can see, there are two bytes. The first byte contains the MQTT control packet type and flag specific to each MQTT packet type, and the second byte have the remaining length. MQTT control packet type occupies 4 bit, that is 7 to 4 bit position. This 4 bit is an unsigned value and each value represent one MQTT control packet type, and the remaining bits, that is 3 to 0 of byte 1 in the fixed header, contains flag specific to each MQTT control packet type. The remaining length is a variable byte integer that represents the number of bytes remaining within the current control packet, including data in the variable header and the payload. In the more informal way, remaining length is nothing but the length of variable header plus length of payload. We will see remaining length in detail in the later part of the course. Now, these are all the MQTT control packet type with 4 bit unsigned value and its direction of flow. As you can see here, every command is followed by the acknowledgement command, like connect have acknowledgement connect, publish has pubback, pubrec, pubdel and pubcomp, subscribe have subpack and unsubscribe have unsubpack. Now, these are all the flag value associated with the command. Here, the reserved refer to the future use. That means it is not being used right now. As we are seeing in the publish command, the flag bit are further subdivided into DUP, which stands for duplicate delivery of publish packet, QoS, which stand for Publish Quality of Service, and Retain, which stand for Retained Message Flag. The important point to note here is that if there is an invalid flag are received, then it is a malformed packet. Let's look some important point about the remaining length in the fixed header. The remaining length is a variable byte integer that represents the number of bytes remaining within the current control packet, including data in the variable header and the payload. In the simple term, remaining length is the length of the variable header plus length of the payload. That is, for example, if the variable header length is 10 and the length of payload is 20, then the remaining length should be 30. Right. So remaining length can be used up to 4 byte. Remaining length start from the second byte and it is used up to 4 byte. It uses 7 bit for the length and the MSB bit is used as a continuation of flag. If the continuation flag is 1, it represents next byte is also a part of the remaining length. If the continuation bit is 0, it represents byte is that byte is the last one of the remaining length. Now let's see some important point about the variable header. Some types of MQTT control packet contains a variable header component. It resides between the fixed header and the payload, as we have seen earlier. The content of the variable header varies depending on the packet type. The packet and identifier of the variable header is common in several packet types. The variable header component of many of the MQTT control packet type include 2-byte integer, that is packet identifier field. The packet identifier field of variable header is common in several packet types. The following packet contains a packet identifier. These are the following packet, just like publish, pavac, pubrec, pubdel, pubcom, subscribe, subback, unsubscribe, unsubback. Let's see some important point of packet identifier. A publish packet must not contain a packet identifier if its QoS value is set to 0. That is, quality of service value is set to 0. So whenever I am telling about the packet identifier of publish message, then it means that its QoS is greater than 0. Each time client sends a new subscribe, unsubscribe or publish MQTT control packet, it must assign it a non-zero packet identifier that is currently unused. The important point is that is currently unused. Each time a server sends a new publish MQTT control packet, it must assign it a non-zero packet identifier that is currently unused. A pubback, pubrec, pubdel or pubcom packet, which is the acknowledgement command of the publish, must contain the same packet identifier. The important point is it contain the acknowledgement command of publish contain the same packet identifier as the publish packet that was originally sent. A subback and unsubback, which is the acknowledgement command of the subscribe and unsubscribe command respectively, must contain the packet identifier that was used in the corresponding subscribe and unsubscribe packet respectively. The packet identifier becomes available for reuse after the sender has processed the corresponding acknowledgement packet. Just like if the QoS is 1, then the publish have acknowledgement pubback. So if it process the pubback, then that packet identifier is again reusable. Now let's see some important point about the payload. Some MQTT control packet contains a payload as a final part of the packet. The payload field usually contains the data which is being sent. This is the message content. For example, for connect packet, the payload is client ID and username and password. In publish packet, payload is just a message. Now, these are all the command list which have payload field and some have not payload field. Like in connect, payload is necessary. Connect, acknowledgement of connect, so there is no payload. In publish, this field is optional. Payload field is optional. This is the important point. All the acknowledgement of publish does not have the payload field. In the case of subscribe and unsubscribe, the message packet have payload field and its acknowledgement. Subpack and unsubpack also have the payload field. Today I am taking the example of publish message format, and also we will understand the different level of MQTT quality of service. Now let's get started. This is the message format of publish command of MQTT. The control packet type of publish is 3. So that's why the first 4 bit is written as 00011. And as we have seen in the previous lecture that in publish command control type flag bit is subdivided into DUP, QoS and retain. And the second byte is the remaining length. These 2 bytes consist of the fixed header. As we have seen in the previous lecture that this fixed header is always present in all of the command of MQTT. The variable header of MQTT contains the topic string length, topic name, and packet identifier, which is also a message ID. And lastly, payload field of publish contain the message which has to be sent. So, the topic name with the topic name string length consists of the name of the topic which the message is published, to which the message is published. The first 2 bytes of the topic name field indicate the topic name string length. Okay. Message ID, which is a packet identifier, as we have already seen the packet identifier properties in the previous lectures. So, a message ID is present if QoS is greater than 0, that is, QoS is 1, that is at least once delivery, or 2, exactly once delivery. We will see QoS in much more detail in the later part of the course. Now, publish message, which is nothing but an array of bytes. The structure of publish message is application specific. Now, let's see some important point about DUP, QoS, and retain. DUP flag. If fresh or new published message is there, then it has set to be as 0. Or if it is a redelivery, then it has to be set as 1. QoS level. This flag represent the level of assurance for an application message delivery. 0 represent at most 1 delivery, 1 represent at least 1 delivery, 2 represent exactly once delivery. As you see in the table. Here 1 is reserved, which is not being used. Retain. If retain flag set as 1, that means that application message must be stored. If flag set as 0, that means that application message must not be stored. Now, let's understand the QoS in much more detail. As we have seen in the previous lecture that MQTT uses TCP/IP protocol for data delivery. But even though TCP/IP provides guaranteed data delivery, data loss can still occur if TCP connection breaks down and messages in transit are lost. Therefore, MQTT adds 3 quality of service level on the top of TCP. QoS level 2, which have semantics of exactly once delivery of message. QoS level 1, which have a semantics of at least once delivery of message. QoS level 0, which have semantics of at most one delivery of message. Level 2 is the highest level of quality assurance. Now, let's start with QoS level 0. QoS level 0, a message delivered with at most once delivery semantics. Messages are delivered according to the delivery guarantee of underlying network of TCP/IP. So, where this QoS level is used? Let us take an example of temperature sensor data. Temperature sensors data, which is regularly published, loss of an individual value is not critical, since applications will anyway integrate the value over time and loss of individual sample is not relevant. To understand the QoS level 0 more clearly, let's look at the message flow diagram. The client publishes message to the server and the server publishes message to the subscriber, and without any acknowledgement is received, the message is deleted by the client. So, the assurance that the data is received by the subscriber is very low. So that's why it is also termed as fire and forget. Now, let's see QoS level 1. QoS level 1 afford at least one delivery semantics. Messages are guaranteed to arrive, but there may be duplicate. That is, if the client does not receive the acknowledgement command pubback in time, it resends the message. The application example of QoS level 1 is a door sensor senses the door state. It is important that door state change just like close to open or opens to close are published lossless to the subscriber. Applications simply discard duplicate messages by evaluating the message ID field. Let's understand the QoS level 2 with the message flow diagram. Firstly, client store the message and publish the message to the server. The server store the message first and then publish the message to the subscriber. After some time, the server delete the message and send pubback acknowledgement to the client. After receiving the acknowledgement, the client delete the stored message. In this flow diagram, you have seen that acknowledgement work at one level, so it give more assurance of message delivery than QoS level of 0. Now let's move forward to QoS level 2. QoS level 2 affords the highest quality delivery semantics, that is exactly once, but comes with the cost of additional control messages. We have to use more than 2 acknowledgement. We will see. This is the highest level that also incurs most overhead in terms of control messages and need for locally storing the messages. It is important to note that exactly once is a combination of at least once and at most one delivery guarantee. The application example of QoS level 2 is where the duplicate event could lead to incorrect actions. Example, sounding an alarm as a reaction to an event received by a message. Let's understand the QoS level 2 using message flow diagram. Firstly, the client store the message and then publish to the server. Server stored that message and publish to the subscriber. And after that, the server sends the pubback to the client, pubback acknowledgement to the client, and thereafter the client sends the pubback acknowledgement to the server. After receiving the pubback, the server deletes its stored message and send pubcom acknowledgement to the client. The client receives pubcom acknowledgement and delete its stored message. As you can see here, the acknowledgement level is more than 2 and hence it assures the exactly once delivery of message. That's why it is the highest level of quality of service. Let's do some hands-on practice to use MQTT. Before starting the coding part, it is important to know some important point about MQTT client and subscribers. Like multiple client can publish to the same topic. A client can only publish to an individual topic. It is very important. So, if you want to publish a message to two topics, you need to publish the message twice. A client can subscribe to individual or multiple topics. It is also a very important point. If the published message to that topic for which there is no subscriber, then that message is discarded by the broker. In MQTT, we are not able to know the identity of the client which published the message. Now, let's discuss some important point about the topic. MQTT topic is just like an address that allows client to share the informations. Topic names are case sensitive. Topics uses UTF-8 string format. All topics are created dynamically. When someone subscribes a topic or someone publishes a message to a topic with the retain message set to true. I have already discussed the retain in the previous lecture. These topics are not permanent. Now, let's discuss little bit about the topic structure. MQTT topics are structured in a hierarchy using forward slash as a delimiter. Let's take an example to understand it clearly. It is just like an address, a folder and file in a file system. just like slash, house, slash room slash main door, house slash room slash side door, like that. In MQTT, subscribers are often interested in a greater number of topics because individually subscribing to each topic is time and resource consuming. So in MQTT, client or subscriber can subscribe to individual or multiple topics. When subscribing to multiple topics, we have to use wildcard. There are two wildcards, has character wildcard and plus character wildcard. Has character is a multi-level wildcard and the plus character is a single level wildcard. We will see in detail the has and plus with the example. Let us take an example to understand both the wildcard clearly. Suppose there is a IoT based door opener. So to receive the correct command, we have to subscribe to appropriate topics. So if we subscribe to topic house slash has character, then it will cover the topic like house slash room 1 slash main door, house slash room 1 slash bell ring, house slash garage slash main door, house slash main door. That is, if you see the pattern, it subscribe to every topic which is followed by house slash. If we use plus character, then if we subscribe to topic just like house slash plus character slash main door, then it covers house slash room 1 slash main door, house slash room 2 slash main door, house slash garage slash main door. But it does not cover the topic like house slash room 1 slash side door, house slash room 2 slash side door. That is subscribe the topic which start with house and end with main door. Now, to understand why has character wildcard called multi-level wildcard and plus character wildcard are also called single level wildcard, let's take a topic tree. The tree shown in the figure is called topic tree. This visualization of topic hierarchy enable you to understand the wildcard easily. Multi-level wildcard, which is has character wildcard, matches multiple topic level. For example, building slash floor 1 slash has. It matches all the node under building slash floor like building floor 1 blinds, building floor 1 sensors, building floor 1 sensors light, building floor 1 sensors temperature. If we use hex character like this, means it is between the string, then it becomes invalid. Hex character must be last character in the topic string. So as we see here that it matches multiple topic level. So that's why has character wild card are also known as multi-level wildcard. Now, let us understand a single level wildcard which is also a plus character wildcard. Basically, it matches one topic level only. Let's take an example to understand how. Let us take an example. Just like building slash floor 1 slash plus. If it is the topic, then it matches building slash floor 1 slash blinds and building slash floor 1 slash sensors. We can use plus wild character between the string, just like building slash plus slash sensors. If we say building slash plus slash sensors, then it matches building slash floor 1 slash sensors and building slash floor 2 slash sensors. So here also we see that it matches only one topic level. So that's why plus wild character are also known as single level wildcard. So I think that you are able to understand the basic difference between plus and has wild character. And also I hope that you understand the different important points which is going to be used in the implementation part. Today we will going to see the implementation part of the course. Let's get started. As we now know that the key component in MQTT is the MQTT broker. Mosquitto is an open source broker that implements the MQTT protocol. It's lightweight and switchable for use on all devices like Raspberry Pi and on PC. In this tutorial, we are going to use cloud-based Mosquitto broker that implements MQTT broker. Because the cloud-based broker make device controllable over the internet and hence you are able to make awesome IoT project which uses internet to control remote devices. Cloud-based Mosquitto broker are mainly like ThingMQ, ThingStudio, MQTT.io, HeroQ, and CloudMQTT. We are using CloudMQTT in this tutorial because CloudMQTT is one of the best and easiest cloud-based Mosquitto broker. CloudMQTT has a free plan that allows us to set up our own Cloud MQTT broker instance. That instance will run on their hardware server. It also has a well-designed GUI to monitor the publishing and subscribing process and topics through an easy-to-use WebSocket UI. In this lecture, we will be using Paho MQTT library of Python. The easiest way to install this library is by using pip command. Just type in a cmd pip install Paho MQTT. The core of the client library is the client class. There is a client library in a Paho MQTT and the core of that client library is client class which provide all the function to publish, message and subscribe to the topic. Paho MQTT client class has several methods. The main ones are connect command, connect method, disconnect method, subscribe method, unsubscribe method, publish method. These are, we have also seen these are the command in MQTT. I am using Windows operating system in this implementation lecture series, but these all things is also applicable to Ubuntu or Linux. So if you have Ubuntu operating system, then these all things are applicable on that operating system also. Now, firstly, we have to log in to the Cloud MQTT and we have to make an account on that Cloud MQTT website. And after that, we have to create a broker instance. Let's do it. Just search Cloud MQTT on the Google. Just Cloud MQTT in Google. The website on it. Here you have to create an account. I am using Google account to log in this website. So using Google, I have logged in into the website. You are seeing here create new instance. By using this button, I am going to create the broker instance of MQTT on their server or Cloud MQTT server. Let's do it. Here you are seeing a name. So I am giving the broker name as first code. Plan is cute cat. That is free, but it have a limited access. Here tag is optional. So just click on now select region. Here you can see data center. Here two data center is provided. I am using first one and then click on review. Here you see the configuration of the broker. As I have provided the name as a first code. Provider is Amazon Web Service. Region is US East 1. Now just click on create instance and it will create the instance of the MQTT broker. As you can see here, the first code name, it is created, instance successfully created. So now click on the first code. Here you see all the details like broker details like server name, user, password, port, SSL port, WebSocket port, connection limit is 5. Because it is a free plan, that's why we have only a 5, connection limit is set to 5. If you want more connections, then you have to purchase the plan. Now, the broker instance is created. We will use this information. We will not use all the information. We will use some of the information like server, user and password and port to do data transfer from client publish the data to the broker instance, which is hosted by the CloudMQTT. And also for a subscribe, we will use 4 information from here. So you just create one account here and try to do with me. One is my computer in which I am developing a program of client to work as an publisher and subscriber, and another client I am using my Android mobile phone. Yes, I am using another client, my Android mobile phone. In my Android mobile phone, I have downloaded one app named MyMQTT. As you see on the screen, you are also able to download this app in your mobile from Google Play Store. Just type MyMQTT. This app make my mobile to work as a publisher and subscriber. So, firstly, I will make my computer as a publisher and my mobile phone as a subscriber. As you know that, it means computer publish message to the broker and received by the mobile phone. And then I will make my computer as a subscriber and my mobile as a publisher. So in this case, my mobile phone publish the message to the broker, that is CloudMQTT Broker, the instance of CloudMQTT Broker, and message is received by my computer. So you are able to see in when I will write the code for the publisher and subscriber. So you are able to see that. I hope you are all enjoying the tutorial. So let's do some hands-on and let's jump directly to some coding to make this really happen. Hello everyone. Welcome to the Programming Knowledge. I hope you are all doing well. In the previous lecture, I had shown you how to create a Cloud Mosquitto based broker instance on CloudMQTT. I hope you are all now familiar with CloudMQTT functionalities and you have created one account so that you are able to follow the tutorials. I have also told you to download the app name MyMQTT so that your mobile phone become the client and work as a publisher and subscriber. Now, let's get started. I am using Python idle for coding. I have already installed Paho MQTT. If you have not installed this library yet, then just type pip install paho-mqtt in the CMD. Okay, now jump to the coding part. As I said before, first I will write code such that my computer work as a publisher and my mobile phone as a subscriber. I am using two clients because it is easy to visualize the message flow. So today I will write code for publisher, and to make my mobile phone as a subscriber, we have to do some setting. Open the app and go to the settings section. Here you have to provide the broker instance detail which was discussed in the previous lecture. The details is like broker URL, port, username and password. Username and password is optional. Even then, I am filling it out. So let's fill all the information. Now, your mobile client is ready to act as a subscriber. Now, let us suppose my computer is publishing the message on topic like MQTT/first code. I have already discussed the topic structure in the previous part of the video. So if you are not able to understand how I write the topic, then watch that lecture and again come and continue from here. So in subscribe section, add the topic MQTT/first code. As you see here, you are now subscribed to the topic. As I said before, a client can able to subscribe multiple topics. So you are able to add many topics here. So if now any client publish the message on this topic, then that message is received by my mobile phone and it will be seen by the dashboard in this app. Now let's make my computer to act like a publisher to this topic. Let's open the idle Python IDE. First, we need to import the client class to have the access to all the functionality needed to connect to the broker and publish some messages to the topic. This class provides a very simple interface so that we don't need to worry about the low level detail of the MQTT protocol. So let's import paho.mqtt.client as MQTT client. Okay. Additionally, we also use time module. So import Python time module because we can have access to the sleep function for introducing some delay in our code. Now, declare the variable that is connected. The connected variable is set to false. We will see later why we are setting it as false. Additionally, now declare 4 variable to hold the information needed to connect to the server. This is the information mentioned in the previous lecture to connect to the server. You should use the information from your broker instance which we have created in the CloudMQTT. So let's define broker address, port, user, password. Now, and also keep it in mind that broker address, user, password are in string. Type is string. Okay. Now, create a new client instance. We will pass as argument of the constructor a unique client identifier in a format of a string. The client constructor takes 4 optional parameters, but only the client ID is necessary. And also, it is very important, it should be unique. as we have discussed in the previous lecture of the important points of MQTT. So let's define the instance. Client is equal to MQTT client dot client, and let's suppose we are passing the string MQTT as a client identifier. Okay. Now we have to call the username password set method. This method allows to specify a username and password. Here password is optional also. So let's client dot username pw set password, and passing the argument user, which we have already defined, comma password. Now here we have to specify a onConnect callback function, which is called when the broker responds to the connection request. As the callback function, to process callback function, you need to create a callback function to process any message, and we have to start a loop to check for a callback message. I am just assigning the function for now and define the actual code later. So client dot on connect is equal to on connect. Okay. Now finally I am calling the connect method for establishing the connection to the broker. It takes as the input the broker address and the port number. So client dot connect broker address comma port number. As I have already told that if to process a callback function, we have to call a method called loop start. It also run a thread in background to handle the network connection, and also it handle the sending and receiving data. So client dot loop start. Since establishing the connection may take a while, so I am writing a loop so that the loop is executed until the previously declared connected variable is set to true. As I said before, the connection variable is set to true in our callback function. We are going to define call on connect callback function later. Now, while connected is not equal to true and time dot sleep, let's suppose we are delaying for 0.2 seconds. Okay. Now we have to publish the message to the broker. So as I have already defined the topic structure, so suppose that the topic is MQTT slash first code, and we are passing the message hello MQTT. Okay, now we have to stop the loop. Now to finish the coding, we just need to specify the onConnect callback function. It receives 4 arguments. So define onConnect. So it take 4 argument like client, user data, flags, RC. Here RC value determine that the client is connected to the broker or not. If RC is 0, then client is connected. So if RC equal to 0, we will print uh, client is connected to the broker. Here, if RC is equal to 0, we have to set connected is equal to true. So connected is a global variable. So first we will initialize global connected and then we will initialize connected is equal to true. If RC is not equal to 0, then we will print connection failed. That is, client is not connected to the broker. So else print connection failed. Now let's run it and we will see it tries to means it publish the message on this topic and the message is hello MQTT. Yeah, it is gets connected and yeah, here you can see we get a message on this topic MQTT slash first code. I hope you all understand the coding part of the MQTT. I am also giving you the code in the description box. You are able to download from there. Today we will make my computer as a subscriber and my mobile phone as a publisher. Let's start coding to make my computer as a subscriber. Here all the things are same as in the previous video, like firstly I am declaring the connected variable and it's set to false, and also we will declare message received and also it is set to false. We will see later why I am declaring this variable. After that we have to declare 4 more variable, and this variable contains the broker instance information. This information is like broker address, port, user and password, like in previous lecture. Now we are going to create a new client instance and we will pass the argument client identifier. I am passing the MyMQTT string as a client identifier, same as before. To set password and username, we have to call username password set method, and it takes argument like user and password. Here password is optional, but even then I am passing it. Now we have to specify a onConnect callback function, which is called when the broker responds to the connection request. I am just assigning the function for now and define the actual code later. Finally, I am calling the connect method for establishing the connection to the broker. It takes as input the broker address and the port number. As I have told that to process a callback function, we have to call a method called loop start. And this method also run a thread in background to handle the network connection and also sending and receiving data. Now, we need to call the subscribe method and we have to pass the input as a topic as an input. That topic that we want to subscribe to. In this case, we will subscribe to topic like in the previous lecture, MQTT slash second code. So now any client published to this topic, then that message is also received by my computer. Since establishing the connection may take a while, so I am writing loop so that loop is executed until previously declared connected variable is set to true. As I said before, the connected variable is set to true in our callback function, which we are going to define later. Now, to get a message, we have to wait for some time, so that some client publish a message to the subscribed topic. Okay, so I am writing a loop for that also, so that loop is executed until previously declared message received variable, which we have declared previously and we have set to false. Now here we will execute the loop until previously declared message received variable is set to true. Set to true, yeah. In this case, also the message received variable is set to true in callback function. Okay. Now to finish the coding part, we just need to specify the onConnect callback function and onMessage callback function. OnConnect callback function is same as before. Like if RC is equal to 0, then print a success message that client is connected to the broker, and otherwise print an error message or client is not connected to the broker. Now to see that message is received by the client, we have to define one more callback function. This callback function is executed when client, that is my computer, receives a message. So here I am just assigning the onMessage callback function, and later we will define the onMessage callback function. Now let's define this onMessage callback function. It takes argument like client, user data and message. So define onMessage. If message is received, we know that the message is in UTF-8 string. So first of all we have to decode it. So we have to decode that message. So how we are accessing the messages, there is a payload member of the class. This payload will be used to get the actual message received from the subscribed topic. So we will print like message received. Now here we are also able to get topic on the which the message is published. Like you have to only write message.topic. Just like message.payload, here you have to write message.topic and you have to print it. Okay. Let's run this code. As you see here, client is connected. Now in the app, we have to provide the topic in which we want to publish the message, and the computer is subscribed to. So here I am typing MQTT/second code. And now here we have to write the message hi. I am writing hi, and yeah, as you see here, the message is received hi, and the message topic is MQTT/second code. Now again, let's publish message hello from my mobile phone, and let's publish it. Yeah, as you see here, the message received is hello, and the message topic is MQTT/second code. So I hope you're all able to understand the MQTT publish and subscribe coding part, and thank you guys.